Just a heads up, I'm at the library, so if you hear some people talking in the background or an elevator dinging, it's because I am at the library. Your I can statement for today is I can use models to multiply a fraction by a whole number. So what we're moving towards, instead of adding and subtracting fractions, we're going to work on multiplying fractions, and eventually we will get to the place of multiplying fractions together. Your sample problem for today is Sasha walked 1/2 mile every day for 5 days. How far did she walk? And since we're using models today, we're going to use the number line below to help us solve that problem. So let's start with our cubing strategy. We're going to circle any key numbers. So I'm going to circle 1/2 and 5. I'm going to underline the question. How far did she walk? I'm going to box any key numbers. So we have mile. I'm going to box every because I know that she walked every day, not every other day. I'm going to eliminate anything that I don't need. And then I'm going to solve. So I want you to take a minute and figure out how you would go about solving this. You're being asked to figure out how far Sasha walked if she walked a 1/2 mile every day for 5 days. So just take a minute and see if you can figure out how you would solve this problem. Okay, so if you were to use the number line to model multiplying a fraction by a whole number, I wouldn't even write an equation. I would just start at 0. I would start at your starting point on the number line, which is at 0. So this is where Sasha started, and on day 1, she walked 1/2 of a mile. So I move 1/2 of a step. On day 2, she walked another 1/2 of a mile. Day 3, another 1/2 of a mile. Day 4, another 1/2 a mile. And finally on day 5, her last 1/2 mile. So right now I'm at this point of how far Sasha walked because she walked a 1/2 mile every day for 5 days, which tells me that she walked 2.5 miles total. That's how far she walked. If I were setting up an equation for this, I could say 1/2 times 5 equals question mark, because that's what I'm trying to solve. And I know that with my whole number, anytime I have a whole number, I can put that whole number over 1 and it will still be the equivalent number or the same number. And then I could just multiply across. So this would give me 5 times 1 is 5 and 2 times 1 is 2. Now the tricky part is turning this improper fraction into a proper mixed number. So what you'd have to do is ask yourself, well, how many times does 2 go into 5? And we know that's 2 whole times. And what we have left over is 1 over 2. But for today, I don't want you to focus on this equation. I want you to focus on modeling. So using a number line or repeated addition to help you solve this. So again, all I did was make a number line. I started at 0 and I hopped a 1/2 mile 5 times for every single day that she walked, which gave me 2.5 miles that she walked in total. Our sample problem says Joanne wants to make 6 batches of fruit punch. She needs 2/3 cup of orange juice per batch. How many cups of orange juice does she need in all? So I want you to try and solve this first on your own, and then after you solve it and you think you have the answer, I want you to hit next on your notes and listen to how I talk you through it. Okay, so we're using models again, remember. You don't necessarily need an equation. So there's a couple ways you can solve this. You can start with repeated addition, which means that here I have 1, 2, 3, 4, 5, 6 batches of fruit punch and 2/3 cups of orange juice in each batch. As you can see, 2 are shaded out of 3. I can do repeated addition for these, knowing that each thing is 2/3. Each batch has 2/3 cups of orange juice. So if I add each of these together, 2/3 plus 2/3 Just going to keep writing 2/3 6 times. I have a common denominator of 3 in each of my fractions, so I can easily add all of these together. So remember, I leave my denominator alone. That always stays the same when I'm adding. When I'm adding, my denominator stays the same. So that's 3. And then I'm going to add my top, my numerator. So 2, 4, 6, 8, 10, 12 thirds. Now remember, this is an improper fraction and we need to turn it into a mixed number. So let's ask ourselves how many times 3 goes into 12. Okay, hopefully you got 4 times. It goes in 4 times because 3 times 4 is 12. So your answer is 4. For how many cups of orange juice does she need in all? She needs 4 cups of orange juice.